Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Today's problem seems like a very simple one. We have a body that goes from A to B with a constant speed v, then it reaches point B, turns back and goes with the speed v, and all they want to find us, they give us time, and they want to find us distance, displacement, and build us the graph. Oh well, let's start with the velocity. V over t. So, as the body goes from here to here, velocity is constant. Let's put this v0 and this v0 to... v is like an axis and v0 is a value. So with this v0, whatever time is, v is v0. Doesn't change. If the value doesn't change, the graph is horizontal line, no matter what it is. Pressure, volume, temperature, or speed. Speed is the same, time changes, speed is not, the graph is horizontal line, and it's all until this time t0. t0 happens, and the graph becomes negative, and it goes back, and this is 2t0, and that's it. So what happens with the x itself? If we put here the x and we say that this is 0 and we tilt it so it's easier for us to see, so this would be A, this would be B, and this would be distance d, so this value is d. So what happens is that the graph horizontal and x, and this is the same time t0, and it is the same time 2t0, and I always have to put t and arrow. So this is my graph. So x is growing linearly, and this is the formula. And the formula here, x equal vt. So no matter what t from here we will take, we take this v0, and multiply it by time, and it grows. The more the time, the more value of x, and finally when we reach this point, we have d equals v0 multiplied by t0, because this is a moment t0. And of course, I told many times, and it's like a fact, that this is t0, this is v0, so the area of this rectangle is t0 multiplied by v0, and that's exactly what it is. And if it would be different time t, this area of this would be t multiplied by the same v0, t multiplied by the same v0, and this area would become an x at the moment of time t. But when we have this area becomes x at the moment at t0. So this is like how the graphs are built. Okay, now what happens when we use this approach of calculating the area and we come to this? After that moment, v becomes negative. So that means that the graphs go down. X, the coordinate, becomes smaller and smaller, and at the moment to 0, x becomes 0. So the graph of x go up and down. But distance that we cover cannot go down. We travel to some point to school, and then we go back, and it's double distance. You pay for the gas twice, you pay for the bus ticket twice, and if you walk, you spend twice as energy, because the distance can only grow. So, what does that mean? For the areas where v does not change direction, it stays always positive, for example. There is no difference between coordinate and no difference between the distance. But the moment v becomes negative, right here, coordinate becomes decreasing, but distance is still increasing. So, if we put it in a generic terms and put v and put t, and we have this. So, this would be the area that grows, and to this area we have to assign negative sign, because it's negative, because v is less than 0, below the axis. If we still want to use this idea that the area under the graph of v from t, this area, is equal distance, we have to put an absolute value. We have to negate the sign so it becomes positive again. And then we calculate the area under this graph. And this becomes the distance. So the area under the real graph becomes like x or displacement. And the area against positive graph, mirrored one, absolute value, this area becomes the distance. So if we will turn it here, we will see that v is the same, as if the same, and distance grows, and we cover double 2d. In 2t0 multiply v0 equals 2d. Well, this is the way it should be, double, right? So, what is then distance and displacement? Displacement actually is a vector. If the body moves somehow like this and starts from here, this is displacement at that moment of time. This is displacement at next moment of time. This vector is displacement here. And eventually it becomes this, and eventually becomes 0. In this case, when we're moving along one line, our displacement is this, then our displacement is this, then our displacement is this vector, then our displacement is here, then we come here and it's our maximum displacement, and then we turn back and our displacement becomes this vector, this vector, this vector, this vector, and then it disappears. But because we're not dealing with vectors, we're dealing with one dimension, our x goes, decreases, and our displacement becomes 0. So we have to be careful when you're drawing graphs in one and only one aspect. That is, for the areas when value becomes negative, you have to flip it and take an absolute value. That's the difference between distance and displacements. Distance always grow, displacement when may become smaller, may become negative, it may become, well, when it will be negative? It will be negative if we will go from here to here and then come here to some point C. Then displacement, the coordinate would be negative, minus 2 kilometers, for instance. And then displacement on this graph will go even further down. But for all goods and for all purposes, remember that if the speed does not change direction, doesn't become negative, distance and displacement are the same. Distance increases and displacement increases with this. And so this concludes this simple problem, which is not a problem, but just simply explain what's the difference between displacement and the distance. So please don't forget to like, don't forget to subscribe, don't forget to click bell. If you have your own questions and comments, please put in the comment section. You're very welcome to do this. If you have an interesting problem that you can solve put it there. I'll try to address it in the playlist from our users. And thank you very much for visiting. See you soon.